Yep, that works. Okay, good, thank you. So anyway, I'm Thomas Dinsmore. I work for a company called Revolution Analytics. I'll mention our product, but I've gone to considerable length to make sure this is vendor neutral. I'm not plugging our product. So this is about advanced analytics in Hadoop. So just an overview of the agenda. First, some definitions, which if you've worked in analytics for more than 5 minutes, you know that there's just a cloud of lingo and hype and jargon and so forth. So the first thing I'm going to do is define the scope of this presentation. I'll talk a little bit about architecture for advanced analytics in Hadoop, and then talk about some of the currently available open source and commercial offerings. Sorry, a little trouble. There we go. Okay, so as I said before, in analytics there's this cloud of terminology and concepts, and everybody is an analytics platform and so forth. But you have everything from data access and data manipulation to that center column of BI type stuff, queries, reports, scorecards, blah, blah, blah. And over to the right-hand side with growing computational complexity, things like text analytics, advanced discovery, such as clustering, graph engines, and so forth, predictive analytics, blah, 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 blah. All right, so just again to define the scope, although you can spend a lot of time on data integration and BI, I'm not going to do that tonight. So we're just going to focus on the right-hand side and just a little bit more scoping. First of all, optimization, and again, this is about advanced analytics in Hadoop, right? Even the largest, say, constrained optimization problems tend to be matrices that you can solve on a single server. So we'll just drop that out. Ditto with simulation. Simulation is embarrassingly parallel to the extent that you have a very high performance requirement for simulation. Folks are using graphics boxes and so forth rather than Hadoop. Geospatial is a very specialized field. I'm not going to talk about that. Econometrics, ditto, and also that uses some of the same capabilities. Having a little there we go. Econometrics and streaming analytics, we could talk for an entire hour about that as well. So that's gone. So let's subdivide text analytics a little bit, because within text analytics you have feature extraction, which is the actual detection of various words and so forth in the text, the kinds of things you use Lucene or Solar for, or other kinds of text text mining tools. Again, it's embarrassingly parallel, but the really hard part, the really computationally complex, is the dimension reduction that you do at the end of the text mining process. So this is the scope of what we'll talk about today. And again, I don't mean to offend or slight anyone that works in other areas. Those are all very important subjects, but we only have so much time. So, do we need to run analytics in Hadoop? Now, you might wonder why I would even ask that in a meetup that's about big data and visualization, right? But there is a legitimate question: do you actually need to run your analytics inside Hadoop? And the reason for that is, okay, so you've got a lot of data, it's in Hadoop, and you want to do something. You want to run, I don't know, a neural network or gradient boosting or something like that. Well, what a lot of people do is they simply pull a sample, they bring it over to their laptop that's running something, SAS, SPSS, Python, R, or whatever. Maybe it's a server if it's a slightly big problem. They pull their data over, they run their whatever it is they want to do. When they're finished, they build a model, so then they write a program to score the data in Hadoop. And it's inelegant and it offends sort of big data purists, but it actually works pretty well in many cases. And it's surprising how many people actually do this, and it works just fine, right? And given that the legacy platforms, whether you're talking about the commercial platforms like SAS or SPSS, or the open source platforms like R or Python, given that those tools are very feature rich and capable and people know how to use them, you'd be surprised, roughly, I would say about 80% of all users that are actually working with Hadoop are actually just doing something like this. However, This approach works well in many cases, but it doesn't work in every case. So it behooves us to understand when it doesn't work. And it's not simply a function of how big your data is, it also has something to do with what you're trying to accomplish. So to begin with, for some use cases, for some analytic use cases, you must use all of the data. It's not an option. You can't sample. Imagine you're a property casualty company and you're using social network analysis to detect fraud networks within your base of claims holders, claimants, policy holders, insurance adjusters, and so forth. So you're looking for unusual connections or networks between these various players. If you sample, the chances are that you'll miss any ring because the rings themselves are fairly rare. Similarly with anomaly detection, you must use all of your data because what good does it do you to detect anomalies in a sample? It doesn't do you any good. The whole point of anomaly detection is to find anomalies somewhere in all of your data because if you're sampling, you're simply going to, chances are, you're going to miss the very rare events. Similarly with affinity analysis, collaborative filtering, clustering, and so forth. So there's this whole class of use cases where the approach of extracting data, bringing it over to a server or a laptop, that just isn't going to work. The other thing to consider, I apologize, I have a little trouble with this clicker. There we go. There are also circumstances where using all of your data is worthwhile, right? In other words, when you sample, you lose some precision. You don't lose a lot, but you may lose something. And so if you're doing something like modeling catastrophic risks, where very small differences in the quality and predictive power of your model can mean massive differences in the amount of dollars you're paying out in claims or lives lost or other things like that. It absolutely pays you to use every scrap of data you can possibly find. And if you've ever worked with people, anybody here who've worked in the reinsurance industry, if you've ever worked with folks in that business, you know that they will do absolutely anything to get a very, very small lift in the precision of a model. Similarly, Foster Provost has demonstrated in his book, and I'll plug his book, I don't get a royalty, but he's demonstrated how you can use very finely grained behavioral data about individuals to improve the quality of predictive models in general. And so he's able to identify a class of cases where if you're just doing sort of standard risk modeling or marketing modeling, you may be able to use all that data to improve the quality of the model over and above what you would get if you, say, sample it. Keeping in mind that sampling allows you to control the number of rows, it doesn't allow you to control the number of columns. And all the evidence indicates that to radically improve the quality of your models, it's the number of columns that makes the difference. And so we see people working with thousands of columns, 500 million columns, right? And when you have that much data to work with, moving it over to a platform on the side is problematic. A customer of ours, a marketing service provider, and I'm having to draw the numbers out of my memory, so I may not have them exactly right, but they get something like 5 billion cookies fed to them a month. They sessionize them into a table that's about 80 million rows and approximately 5,000 columns. And they estimate that it would take them 4 days to extract that data, move it over to a server, and model it. But they have an SLA with their client to report, to update their models nightly. So that obviously isn't going to work. So, assuming that you know that you need to model within Hadoop, you need to run your advanced analytics in Hadoop, roughly a year ago, your options consisted of, first of all, you can use Apache Mahout or Mahout. And by the way, either one of those is correct. I understand that Mahout is actually a pun in Sanskrit or something. But if you look at the Mahout website, you'll notice that they say it's okay to pronounce it either way. So you either use that or you code it yourself. Anyone here that's coded, say, gradient boosting in MapReduce? Okay. I knew that there'd be somebody in this audience who's done it, right? I didn't expect a lot. You know it's not an easy thing to do. I mean, it is impressive when you go to a data science conference and people talk about, oh, I did this in 100 lines of MapReduce, blah, blah, blah. It's not an easy thing to do. And your third option, oh wait, there isn't a third option. That's it, it's Mahout or code it yourself. Is anybody in the audience a contributor to Mahout? Didn't expect any because there are only 3 active contributors. But first, let's digress a little bit on architecture. So your conventional, if you're running SAS or SPSS or whatever, your conventional architecture is that you're just going to reach in and grab data from HDFS and move it right back out again. And that's table stakes. Every single analytics tool can read HDFS. It's like, okay, fine. Now, a couple of products have added some additional tooling that enables you to embed MapReduce or Pig or Hive directly into your, and submit it remotely, right? Which is actually an improvement over because in this model, whatever you need at the most granular level, you're going to copy over to your analytics environment. In this model, you can actually use some in Hadoop tooling to aggregate, join tables, filter, select, and so forth, and those processes at least will run inside Hadoop. And so SAS can do this. There's also a project called the R Hadoop project, another one called the R Heap or R Hype project. These are basically capabilities that enable you to embed one of the technologies, MapReduce, Pig, Hive, right, and then submit them remotely, and they'll run in Hadoop. I might add, if you're going to do that, in most cases, you might as well just log on directly to Hadoop and run them, right, rather than submit them from, because in every case, you need to know the exact syntax for Hive or Pig or MapReduce in order to specify in other words, none of these, whether it's SAS or the R Hadoop project, none of these capabilities will actually interpret or take your, let's say, SAS commands and translate them into MapReduce. You have to know that. So let's just move on to a genuine in Hadoop architecture. So the first to consider is simply MapReduce Push-Down. Now, MapReduce Push-Down, your analytics tool or your analytics application takes the user request and whatever, in other words, if the application has a user-friendly front end, that's fine. If it's a programming language, but whatever it is, it's going to translate that and issue MapReduce commands. So no data is going to move back and forth between Hadoop and your workstation. And let me just add, why this is better. In these pass-through situations, R Hadoop, SAS, things like that, none of those capabilities actually support advanced analytics. The most you can do is things like table joining, or basically whatever you could do in Hive, that sort of thing. Now, with MapReduce Push-Down, now you actually have analytic algorithms that are implemented right on top of the Hadoop cluster. The advantages of MapReduce Push-Down is that it coexists very well with other applications. So far as Hadoop is concerned, it sees, the job tracker sees a request to do something in MapReduce, right? And it doesn't care whether that's coming from Hive or whether it's coming from your analytic application or something else. It integrates, so you have integrated workload management in Hadoop 1. It also is simple to administer from the Hadoop administrator's point of view. The disadvantage is, and this is really quite critical for advanced analytics, is that MapReduce has a single pass through the data, then persist, right, model, which means that for an iterative advanced algorithm, advanced analytic algorithm like logistic regression or k-means clustering, running it in MapReduce is going to significantly sandbag your results. There's another form of latency that they just call the MapReduce startup, which is it simply takes time when you issue a request from your application to have the job tracker create the mappers and so forth to initiate the process. That's not so significant as the problem with iterative algorithms. It's not a problem with things like SQL, right? Because anything that you can specify as a single pass through the data is going to work pretty well. But for advanced analytics, MapReduce is not the best performing way to do things. So then the alternative, and this is just an emerging architecture, and there are a couple of ways that I'll talk about projects and products that implement this, is a co-located in-memory. In other words, an approach that bypasses MapReduce, uses the HDFS data, and in order to make that work and coexist with other Hadoop applications, it has to run under Yarn. Right? And the reason for that is that without Yarn in MapReduce 1, you basically don't have a means of managing MapReduce and non-MapReduce applications at the same time on the same hardware. Yarn enables you to manage multiple workloads in the same environment. The most common form that we're actually seeing commercial vendors sell is what I would call an asymmetric environment. And in an asymmetric Hadoop topology, you have a couple of nodes that are dedicated to analytic processing. The little pointer here isn't working, so I'll just point with my finger the old school way. Those two nodes, right, in this simplified 8-node Hadoop cluster, you have two nodes, let's say, some number of nodes, that all they do is analytic processing, and the remainder of the nodes are your standard MapReduce processing. Now, the benefit of this approach is it's easy to adapt legacy applications. In other words, there are legacy analytic tools that were developed to run in clustered computing environments. They just weren't, they were developed before Hadoop, right? But those tools are relatively easy to shove under Yarn and run them in parallel with everything else. And this approach isolates the analytic workload. The disadvantage of this approach is data has to move within the cluster, because whatever slice of data you have on this node is going to have to move over to one of these analytic nodes. Now, it's better than moving data completely outside of Hadoop, right? But it's still moving data. Also, and I mean, whether this is a disadvantage, I mean, it's just a fact. This doesn't work unless you have Yarn. A lot of Hadoop clusters haven't implemented Yarn yet. Hortonworks is promoting this very actively because in HDP2, they fully support Yarn. Others are going about it more slowly, and so, for example, a customer I'm familiar with a very large Hadoop cluster doesn't plan to upgrade and implement Yarn for at least 6 months, right? So it's just a fact that you can't do this kind of asymmetric topology unless you have Yarn implemented, so that to some degree limits its availability and sort of constrains the ability to use this architecture for advanced analytics. Now, the ideal, the sort of the theorist's ideal architecture is a symmetric architecture. This is just a larger known show, where you have the analytics, the in-memory analytics running on every node, not just a couple of isolated nodes. Excuse me. And this, in principle, should give you the best performance, the lowest latency. Again, the reason that customers may actually be reluctant to implement that is the implications are the amount of memory you're going to need on each node is likely going to be greater than the amount of memory that's on a standard Hadoop node server. And you know, that sounds like nothing burgers, except again, they're folks with 500 to 1,000 nodes. They don't feel like just swapping them out or upgrading the memory on every single machine. Once again, excuse me, it requires yarn. So those two things, the possible need to upgrade the memory on the Hadoop worker nodes, as well as the need for yarn, could constrain this. However, there's no question that this kind of in-memory architecture or memory persistent architecture is going to be necessary for high-performance advanced analytics in Hadoop. Let me just summarize a few points on architecture. So the current best available, or the current champion, is simply what I call MapReduce Push-Down. You can build advanced analytics. There are a number of products available that run in MapReduce. It's stable, it coexists well with the rest of the Hadoop ecosystem. However, performance can be not only relatively slow, but it can be in some cases slower than just running the application outside of Hadoop on a server. So you have a balancing act. On the one hand, you have a cost of moving data. On the other hand, you have a cost of basically a performance penalty of running inside Hadoop as long as you're running in MapReduce. For advanced analytics to sort of move forward in Hadoop, we need a persistent in-memory processing. Now, talk about a couple of approaches that people are taking. Vendors like Cloudera are working on things like ways to pin memory as a sort of a MapReduce 2. However, since Cloudera is also betting heavily on things like Spark, the presumption is that they think that pinning memory isn't going to solve the problem in the way that Spark will. And again, Yarn enables co-location, so it becomes possible to take legacy analytic applications and sort of shove them into Hadoop and put them all under Yarn, and that partially solves the problem. So let's move on to specific products and projects. So beginning with open source projects, and okay, I was disrespectful to Mahout earlier, so I'll make it up. But let's just a little background. It is still, Mahout is an incubator project, still, started in 2007. It is a machine learning library. It is included in most, if not all, Hadoop distributions, and all the distributors claim to support it, although given that it is thinly used, the level of support, in other words, there's one guy at Cloudera that provides essentially all of the Mahout support. Right? That's it. I mean, and that's not necessarily a knock on Cloudera. That's probably all they need given the usage. Very thinly accepted for the reasons I indicated earlier. The project kind of just was like this grab bag of stuff that seemed to lack leadership or any kind of a plan or design. Also because of the need, again, the inherent limitations of MapReduce that I spoke before, I think that people were reluctant to invest heavily in building stuff until something new emerged. Architecture is eclectic, to be kind. However, to give the Mahout team credit, they have recently cleaned up the project. They have deprecated a whole lot of stuff that wasn't being supported effectively, and they are moving rapidly to 1.0 status and a top-level project. Also, as of March, new algorithms must run in Apache Spark, which I'll talk about Spark later, but Mahout now runs in Spark. Now, I'll talk in a few slides down, I'll talk about some of the analytic features in these various projects. But there are good things in Mahout, and I would just say, take a look at it and keep an open mind about it, because the project seems to be moving in a positive direction. That can't be said for Apache Giraph. Apache Giraph is a top-level project. It's a graph engine. It runs in MapReduce, and it got a lot of buzz a little over a year ago because Facebook, a bunch of people at Facebook did a project to build a graph, and they decided to use Giraph. got 11 billion skillion people in their Facebook social network, and they got to work, you know. So there was a lot of buzz about that, and I think people thought it would be like the next Hive. However, the project is completely dead in the water. It is not included in the leading distributions. There is no significant commercial support, and even Hortonworks isn't really promoting it anymore. They haven't released anything in 13 months, and there are no recent code commits on Git. So none of that, I mean, again, all that adds up to people have moved on, right? So where have they moved on? Well, here's one place they've moved on, and that's GraphLab. GraphLab is a Carnegie Mellon project started in 2009. It is a distributed in-memory engine primarily for graph analysis. I just have to stop and ask. Everybody understand what graph analysis is, or a graph engine? All right, it is not a way of making a bar chart. Right? A graph engine is a tool that one uses to construct social networks. It is the basis of things like search engines, path analysis, link analysis, and so forth. Very powerful tool, very hot tool. There's a lot of interest among startups in graph engines because it turns out they do a lot of really cool things. GraphLab, in addition to having the capability to build things like social graphs, they've figured out alternative approaches to problems like clustering and collaborative learning using a graph engine as the basis. So they, in addition to the graph analysis, they support a couple of other machine learning capabilities. You interface from Java, JavaScript, or Python. For commercial support, the folks that started the project went out and got some capital to start up GraphLab Inc., which now provides commercial support for GraphLab. And there is a fairly significant and growing community of users. They're now, I think in late July, they're having their third annual customer summit or user summit, which is actually pretty impressive. The product is distributed independently. It's not an Apache project. However, they recently announced a relationship with Pivotal, so Pivotal will distribute GraphLab as well. Another commercial open source, non-Apache project, is a company called HexData has a pure open source project called H2O. I would characterize it as a captive open source or on the Hortonworks model. In other words, the project is pure open source, right? And there's the business model for HexData is that they will sell you support and customization and things like that. There's no license to use. You get whatever's in the project for free. It is a distributed in-memory prediction engine that can be deployed either as a standalone cluster, can be deployed in Hadoop, under Yarn, or within MapReduce. Either way, they also have a cloud capability. Very strong in prediction, so they've implemented things like gradient boosting and deep learning. They say it's deep learning, and it's a multi-layer perceptron. I'm not enough of an expert in deep learning to know if it really is deep learning, but they're at least marketing it as deep learning. They claim to have a couple thousand users. They have 4 public references, and I personally know of a major property casualty company that's using it and likes it. They have Java, R, Python, and Scala interfaces, and their R interface in particular is very strong. So finally we come to Apache Spark, which may be the most important of the 5 open source projects. Apache Spark, as of February, is a top-level Apache project. So again, it took Mahout 4 years to get to where they are now, 0.9. They're still not top level. Spark went from incubator to top level in about 5 months, right? Spark, the cadence of development and maturity for Spark is breathtaking, to be honest. They're moving incredibly fast. As of May, they are release 1.0. A rapidly growing developer community, more than 100 people contributed to release 1.0, up from about 70 for 0.9 in December. It is a distributed in-memory analytics framework that the folks behind the project, who are all from Berkeley's AmpLab, folks behind the project like to position it as a comprehensive framework that enables you to simplify the architecture of Hadoop, and so that rather than having multiple point solutions, you can have one framework for advanced analytics that will enable you to, in a single project, combine machine learning and graph analysis and fast SQL and so forth. And their position is you actually have to do that in the real world. It offers machine learning, graph analytics. I said I wasn't going to talk about streaming analytics, and I lied, I'll mention it here. And also they offer a fast SQL capability called Shark. Now Shark is not technically part of the Spark project, and I'll explain why in a second. But it's just separated from the rest of Spark, but it's developed by the same people. And it's the Shark is simply Hive on Spark. It is compatible with every conceivable Hadoop storage format. It is, from the get-go, fully integrated with Yarn. Right? So as people upgrade and deploy Yarn, Spark is ready for them. Currently, Scala, Python, and Java interfaces and a rudimentary R interface called Spark R. Full disclosure, my company is contributing to Spark R. Growing ecosystem, it seems like every day there's new announcements. Alpine, MicroStrategy are all now certified on Spark. And it's supported in leading Hadoop distributions. Now, what do I mean by that? Well, you look at the components, NLLive is the machine learning library, GraphX is the graph engine, Spark Streaming is the streaming engine, not surprisingly, and Spark SQL is simply a capability to read ODBs. In other words, it's a capability to interface with, say, Hive or other ODBC, and then Shark, which again is sort of separated from the project. Cloudera supports and distributes machine learning, graph engine, Spark Streaming, and Spark SQL, but they don't distribute Shark because it competes with Impala. And that's probably why, because Cloudera was the first to jump on the Spark bandwagon, I'm guessing that they decided to separate Shark so they wouldn't have a problem with Cloudera. Hortonworks is taking their sort of standard, careful, conservative approach. They're definitely supporting machine learning. The other components, the graph engine, the Spark SQL, Shark, they are taking no position on, since Hortonworks has its own Stinger project for fast SQL. I don't expect that they're going to jump on Shark. And Horton is also aggressively supporting Apache Storm, which is an incubator project that also does streaming. As I said before, I'm not going to talk about streaming because it's a complicated subject, but there is this sort of a question whether Storm or Spark will become the leading contender for streaming analytics. There are also commercial versions. The argument that the Shark sponsors make that you absolutely need to be able to do machine learning and graph analysis together is very compelling. A little bit less compelling for streaming analytics, so that remains to be seen. MapR supports the whole stack. I think they figure they got to do something. And then Pivotal supports the whole stack, but they also support GraphLab. So Pivotal seems to be taking a sort of all the above approach. And IBM Big Insights, IBM has not announced any support for Spark, although they are a platinum sponsor for the Spark Summit on the end of this month. So maybe there's an announcement coming. Anyone here from IBM Big Data? No. Okay. Oops. All right, so here's a quick summary of the status for what it's worth. you can kind of see, in order to be successful as projects, there has to be some kind of commercial support. You can see that 3 of them do. The architectures I mentioned before, Hexdata, Apache Spark, GraphLab are all running in memory, whereas Giraph and Mahout are. And by the way, when I tabulate the features, the analytic features, which I do in the next slide, for Mahout, whatever, I'm only counting those things that actually do run in MapReduce. I just discount anything that runs in a single node. So, as I said before, keep an open mind about Mahout, particularly given that they're rebuilding on Spark, because they actually did, now just I should have put a legend on the slide, but basically, relative to the other projects, I give it 3 pluses and a dark green. It has more functionality than anybody else, right, in the space. I'm not comparing it to commercial software. I'm just within the scope of what runs in Hadoop. So that Hexdata has multiple algorithms running in H2O, gradient boosting neural nets, random forests. In other words, they have a number of different things. Mahout has 1, random forests. Apache Spark has, and I don't remember, they don't have a neural net, but they've got a couple of other things that Hexdata doesn't have. I have this in a more detailed format. If anybody wants to see all the details, just drop me a note. We'll figure out how to distribute it. Or I'll just add in those slides as an appendix. Dimension reduction. Mahout has multiple methods for dimension reduction, which is why I have a customer that is using Mahout together with Lucene and Solar. So they use Lucene and Solar to construct these very, very large matrices of features, 500,000 features, things like that. And then they use Mahout to reduce the dimensionality of that so they can analyze it in a meaningful way. Poor old Giraph is here with a kind of an okay graph analysis capability, but GraphLab is clearly the leader in the category. Spark is very strong in matrix operations. They support a PCA and SVD and a couple of other things. And the cool thing about Spark is that they expose a number of primitives, like somebody will ask me what to explain this LBGFS algorithm and so forth. In other words, they actually expose the underlying algorithms, so you can build more stuff on top of the primitives. And so forth and so on. So again, this is somewhat subjective, but I'll be happy to provide additional detail on how I built this. How are we doing for time?
That's good.
Okay, good. All right, so just to summarize open source, Giraph is toast. Mahout might be recovering from roadkill status, I think, as they move towards 1.0. And if you start seeing people rebuild their algorithms in Spark, you may see, and again, you may see some renewed interest. Again, as of today, there's no sign of that. But again, the team has done a good job of at least cleaning up the mess. Now, what happens going forward remains to be seen. As of today, for graph engines, GraphLab outperforms Spark and GraphX. And Hexdata H2O outperforms Spark MLI as of this moment. But Spark is catching up fast. The Spark team is adding algorithms, adding capability, adding performance improvements, and so forth. So I wouldn't bet on Spark. I wouldn't bet against Spark. I would simply say that as of right now, those other 2 products are very strong. And if you were doing a project today, right, and you needed deep learning, Hexdata is the only game in town, but I wouldn't assume that in 6 months that will still be true. Spark has much more in the way of money and distribution, which is what drives these things ultimately. And being an integrated platform for machine learning and graph analysis gives them an inherent advantage over the products that just do one or the other. So let's take a quick look at a number of commercial offerings. So, and again, I'm only going to talk about commercial software that has analytics that will run inside Hadoop in a distributed form. So Alpine is a product of a company called Alpine Data Labs. They have common roots with EMC and Pivotal, or rather just Pivotal. They were incubated by the same venture capitalist that incubated Greenplum. And when EMC acquired Pivotal, they didn't acquire Alpine, but they have, if you look at the executive team and so forth, you see some very, very close connections to EMC and so forth. It is I would characterize it as a strong business user interface with a very strong collaborative environment. They promote it as a code-free environment. As usual, that's not true. And the reason we know that is every time they sell something, they end up landing a whole bunch of data scientists so if it's code-free, why do you need to sell all these consulting services? The answer is, this stuff is hard. But it is a very nice sort of presentation format for analytics, and customers like it. Reasonably broad library of techniques. They don't stand out in anything, but they cover the basics. I'll get to the analytic features. A strong cloud offering, which is a great way to mask some underlying limitations. It's one of the few products that will run both inside Hadoop and inside an MPP database, in this case Pivotal Greenplum. And of course they can also leverage Pivotal's Hawk SQL engine as well. Within Hadoop, it leverages a push-down MapReduce model. However, they've recently been certified on Spark, and while they haven't announced a product, the fact that they've been certified suggests that they're thinking along those lines. Maybe they'll announce something at the Spark Summit, I don't know. And it's a fairly small but growing customer base, and a pretty sizable A round of venture capital last fall. Good old IBM SPSS. The Analytic Server is a backend for the SPSS modeler product, which is again a very, very nice. The modeler itself is a very nice front end, and Analytic Server is a component that is sold with modeler. Analytic Server takes modeler commands and pushes them down into Hadoop using push-down MapReduce. Fairly limited analytic feature set. It does do a few things. It's release 1.0, so give them a break. It's not limited to IBM Big Insights. That's the way IBM works. The IBM SPSS folks don't talk with the big data folks. And so this runs on Cloudera, Hortonworks, and so forth. No idea if anyone has purchased this or not. The way IBM works is they'll just give out a whole bunch of copies in enterprise agreements. So there's probably some people out there that have this. Whether or not they're using it remains to be seen. But it's a product that's worth noting. This is my company, again, full disclosure. The company's Revolution Analytics. We distribute a product called Revolution R Enterprise, which is a commercial version of open source R. And Scale R is a component that is essentially a component that enables you to distribute or spread your processing, your R processing, over multiple nodes. Last November, we released a version of Scale R that runs in Hadoop, runs in Cloudera and Hortonworks. It also, in addition to a library of distributed statistics and machine learning, it includes tools that will enable you to parallelize an arbitrary R function, such as a CRAN package. It uses MapReduce Push-Down, which again is stable but slow. We also ship with it tools that simplify installation. It is exclusively an R interface. In other words, this is oriented towards an existing R user However, with partnerships with companies like Alteryx, Qlik, and MicroStrategy, and Tableau, there's a capability to use this as a back end to something that has a more of a business-friendly front end. Skytree Server is another product that runs in Hadoop. It was originally a product of a project at Georgia Tech called FastLab. It's actually it's been around for about 15 years. And I don't know the details. I assume like their government funding ran out or something, so they went out and found venture capitalists, and they actually shopped the product around to various folks like IBM, and eventually decided to go as an independent startup with venture capital. It was built originally as a distributed analytics environment, and by all indications, it's fast. The company is very opaque about technical details, so it's somewhat difficult to say, specifically, but you can infer certain things from the claims they make about the product. One is they don't show any kind of nice business-friendly front end, so the presumption from that is what they have is an API. And they do claim to support a range of programming languages, Python, C++, they say. They say they support WCAG and so forth. This is a co-located architecture. In other words, Skytree has its own in-memory, distributed in-memory, but this is, so far as I know, the first sort of legacy product that has used Yarn as a way of getting into Hadoop, and they are now certified by Hortonworks as being able to run under Yarn. Previous to that, I know of a customer, a credit card company, that owns and uses Skytree, and they use it in a beside architecture outside of Hadoop. So I think Hortonworks announced the certification fairly recently. So going forward, you should be able to implement this in Hadoop in an asymmetric architecture. Don't really know how many people are using this. They do have a few public references, and yeah, I use the Wayback Machine, and I check these things. They haven't actually added any public references in at least a year. But again, there are some people that are using this. And of course, the revenue leader in the analytics industry is SAS. Now, there are two different SAS products that run in Hadoop. First is, there's actually a suite of products called SAS High-Performance Analytics, collectively. And as with everything with SAS, you actually may need to buy like 6 different products to get a full suite of machine learning and so forth. But I'm just going to lump them together as HPA. It is a distributed in-memory analytics platform that was originally designed to run in special purpose Teradata or Greenplum appliances. Last year, SAS repurposed this to run in Hadoop. However, there is a problem given the architecture, and the product, basically the way HPA works is it reads the entire data set into memory and uses MPI to communicate among nodes. The implication is you need some pretty big hardware running under this thing. And although I know of there are a couple of customers running this on appliances, I don't know of anyone that's running it in Hadoop, and I know of at least one customer that checked it out and said no thank you, primarily because of the problem coexisting with the rest of Hadoop. The combination of the need to upgrade the entire infrastructure to support it, as well as the inability, so that, for example, unless they've resolved this with Yarn, and I haven't heard that they have, there was an issue that you could not simultaneously run SAS and MapReduce. So that at the Strata conference, like the SAS guys were saying, well, no problem, you run your MapReduce during the day and you run SAS at night, and people throw rocks. Right? So, SAS has lots of money, and they do figure these things out eventually. I wouldn't be surprised if in the next year they do figure out how to make it work. But so from what I've seen, this has not been terribly successful. And possibly one reason that SAS has two in-memory architectures is that possibly because the first one, it hasn't been all that successful. But there is another product called SAS LASR Server, which is the back end for a number of different products: visual analytics, visual statistics, and SAS in-memory statistics for Hadoop. The first one, visual analytics, has been around a couple of years. Visual statistics and in-memory statistics were all released within the last couple of months. SAS has just recently added the statistics and machine learning capabilities to LASR Server. They've got a small library, you know, again, I'm not going to criticize it. It's a reasonable first release, in terms of its completeness. Like HBA, it reads the entire data set into memory. Right now, that sounds unremarkable, except that a 16-core, 256 gigabyte node can load a 75 gigabyte table. So if you've got, say, a terabyte database, do the math, you're going to need a lot of these nodes. And just the license price itself is not cheap. Also, 256 gigabyte 16-core machine is not a standard Hadoop server. So again, there's been some customer pushback. However, that said, I don't doubt that SAS will figure this out eventually. SAS claims to have 1,400 sites, which is roughly equivalent to a box, right? It could be 1,400 boxes in one customer, or it could be 1,400 customers with one box, or somewhere in between. But those folks are all using visual analytics, which is pretty much a BI tool. I don't know if anyone has adopted or has purchased the statistics capabilities for this box. But again, it was just released recently. I think it's worth noting because it's a product that's out there, and if you're working in an organization that's fairly SAS-centric, you'll no doubt hear about it. But as of today, sorry, there's a question?
Yes, as you go through these, you had previous slides where you were talking about sort of functional breakdown, graph analysis, and matrix analysis, and so forth. And are we going to understand that as you go through these commercial products, they do all of those things? They do some of those things? What do they do? What don't they do?
I should pay you to set up the next slide. If I can get this to work. So, just doing the same thing as we did with the open source projects, using the same dimensions. The impression I have is that the legacy vendors are trying to reproduce legacy. In other words, they see Hadoop as a port rather than completely different use cases. Now, I personally don't agree with it. I think that in Hadoop, there will be very different use cases, and analytics that run in Hadoop are going to be quite different than the stuff we learned in college. Right? And there are methods and techniques that have been developed in Hadoop that nobody ever heard of a couple of years ago. They were developed specifically for the problems Twitter was having, figuring out how to do sentiment analysis on this huge stream of stuff. Things like alternating least squares for collaborative learning. Nobody ever heard of ALS before Hadoop, right? Same way with, let's say, latent Dirichlet allocation. And these are things that people maybe thought about, but in Hadoop, these techniques are actually developing and being applied simply because of the nature of the platform itself. So, but the impression I have is that the commercial vendors are really focused. What they're saying is, well, we have, let's say, linear models that runs on a Linux server. Well, let's just be able to give people the capability to run linear models in Hadoop. Now, I'm not saying you don't need linear models, but if you just look at, first of all, I can't think of a single, and again, probably somebody will come up to me and tell me like 27. I don't know of any commercially available graph analysis engines, right, that are, in the same category as these vendors. There may be some startups that do a commercial graph engine, but none of the sort of the established vendors do graph analysis. None of them provide sort of an open SVD or PCA or things like that. SAS has a very strong text analytics capability for HPA. And in their new LASR server, they also have a collaborative filtering capability. But again, the major focus is on the sort of the traditional kinds of modeling. Which sort of leads me to the summary of the commercial. Again, the commercial vendors they don't actually seem to be aware about how people are actually using the kinds of advanced analytics that people are actually doing and to do. I mean, Mahout or Mahout or whatever, people criticize it because it's poorly executed. But the fact is that the people who have been contributing to and developing Mahout were responding to actual needs, and even though some of the things that they built aren't all that great, the fact is they needed them. That's why there's like 9 different clustering algorithms and so forth, because that's the kind of things they were trying to do. The commercial vendors are putting a lot more focus on the last mile, right, on the user interface, and that makes good sense, right? Because the only way you compete disruptively in the analytics marketplace is to attract people that maybe haven't used analytics in the past. I mean, anyone who's an established analytics user has probably already decided, hey, I'd rather just use Python or R or whatever. Right, so for a commercial vendor to come in and do something disruptive, they have to make it look good, right? It's much easier to sell graphics and things like that. So there's much more focus on the user interface. A few specific comments. One is that Alpine's interface is very compelling. I think they've done a good job with that. Hard to say much about the IBM product. It's release 1. I mean, it's limited, but SPSS Modeler has a following. IBM does a good job of sort of selling that product together with Cognos into its accounts. And it's, sort of a solid, well-engineered product like everything else in IBM. Don't talk to me about Lotus Notes. Our product, my company's product, has again, I'm biased, but we appeal strongly to our users, and that's it. And so, someone who doesn't use R probably couldn't care less about our product, but somebody who does, we're kind of like the first stop. Skytree Server does have some pretty good algorithms. Hard to tell. In other words, unless they do some more with things like graph engines, which maybe they'll buy somebody. They do have a nice chunk of capital to work with. Haven't seen any results in terms of customers, but maybe they're just quiet about them. And finally, again, SAS has so much money that eventually they'll figure this stuff out. But again, why two competing in-memory architectures? If I were a customer, I'd be asking, like, which one are you guys actually going to bet on eventually? So just as a recap, if you look back over the past year, we've made tremendous progress in the ability to deliver and run advanced analytics in Hadoop without having to code your own. Spark is maturing it's just astonishing how quickly the project is moving. I mean, a year ago it was nothing. It was like a curiosity. And the Spark Summit at the end of this month is going to be, it's going to be very, very strongly attended. A lot of vendors there. A lot of companies are moving quickly to get onto that in-memory bandwagon. The developer community, the ecosystem are both growing very rapidly. GraphLab and H2O they are also expanding their capabilities and user communities. Can they, is there a niche for them in addition to Spark? Is there room for multiple open source analytics? I don't see why not, but it remains to be seen. And in the commercial space, I mean, a year ago there were essentially no commercial advanced analytics products. Now we have half dozen and probably a few more from startups that I haven't even mentioned. Last I looked in Crunchbase, there were something like 800 startups, classified as analytics. Now, a lot of those startups are doing very targeted, narrowly defined solutions. Social media is hot, that sort of thing. But in terms of tools vendors, I'm sure there are other folks that I haven't mentioned yet. But again, tremendous progress in the past year. Some interesting questions. Will Mahout get a second win? I mean, there's positive signs, there's good stuff there. They've made good architectural decisions. They've cleaned up their act. Is it too late? Again, there are only 3 active contributors. Will people be attracted to that project as it matures, or is it just going to go away? Will MLlog displace hex data, or will hex data merge into MLlog? I don't know. So, similarly, as of today, GraphX doesn't have all the features and doesn't run as fast as GraphLab. How quickly will they catch up? Can Spark Streaming compete with Apache Storm? And commercial, Data Torrent just announced a product that they claim will do 1 billion events a second, which is pretty impressive. It's very competitive. The whole streaming analytics area is very competitive. How quickly will customers adopt memory-centric architectures for analytics in Hadoop? In other words, will people be fairly conservative and want to stick with tried and true MapReduce? Will they adopt Yarn quickly? A couple of questions. Who knows? I don't know. Alpine and MicroStrategy are certified on Spark. What are they going to do with it? If Alpine certifies on Spark and offers a product that uses Spark as a backend, they will have a very hot product, again oriented towards business users. But again, we need to be concerned about business users as well. Will IBM distribute Spark and Big Insights? They're the lone holdout, and I'm not sure why they're holding out, if there's a reason for that, or if it's just a matter of timing. And how long will it take SAS to figure out how to make its products work in Hadoop? And that's it. Are there any questions? Please.
A question about using the open source software versus commercial software. So if I just starting with my programming for, say, certain feature be portable from one system to the other, if in the future I change my mind to use the one system versus the other?
So the question is, if I'm just getting into this, should I start with open source or should I start with commercial? All right. And there's also a third way, which is what I would characterize as supported open source. In other words, a project like Hexdata's H2O is an open source project, but they will sell you support and consulting project. The reason I separated open source from commercial in this presentation is I feel that people tend to make a decision to go one way or the other before they even start evaluating products, right? Open source has the advantage of you know what's there, it's free, in theory, right? But there is no license fee in order to use it. You can open it up, you can see what it is, you can modify it, you can adapt it, blah, blah, blah. Documentation is usually somewhat ratty relative to commercial products, right? Commercial software, you pay license fees to use, typically has much nicer documentation, usually has various kinds of support. There are customers that need that support, right? I mean, there's a reason why SAS has so many customers, because they feel that they need someone to help them with stuff, right? And you know, SAS documentation is very slick, it's very good, it's very thorough. Documentation for other open source projects can be, it varies, right? So open source R documentation for some of the packages is very good, other packages, it's not much there. Does that answer your question?
Yes.
All right. So I mean, how's that for straddling? It depends, right? Please.
Afterwards, who is the major in Sure? Is Sure?
I can't tell you that.
Okay. Fair enough.
Let's just say that you've seen their advertisements. We'll just go with the flow.
What is the question?
Question?
I just have a question. How the latency of response system stacks up, let's say, towards the scuba, which is used by Facebook? I mean, that thing is incredible. It gobbles up an absurd amount of data in sub-second, and then spits out responses for the queries in sub-second, and your max latency for response is under a second.
I'm not familiar with that product, and I haven't seen any benchmarks, but if perhaps we can chat afterwards, I'd like to learn more about it.
I mean, I don't work there. I just said
Key question is, what does it do exactly? Right?
And therefore, I'm trying to understand better because, I mean, the numbers were too expressive. I worked a little bit with the IBM product, and I'm interested, seeing.
And I'm sorry, what is the name of the Facebook product?
It's Scuba.
Scuba. Learn something new every day, right?
That's what Facebook is.
Do you know what it does?
It is it's an in-memory product, and it's a database query type of thing.
Okay. All
I
right.
think it's kind of customized for like Facebook queries. Like if people want to ask, what is the most trending word in Facebook right now? I think that's it for that.
I apologize, I'm old. I can't hear the way I used to, so I'm going to walk over here.
What I was going to say was that it's a campaign product.
This is Scuba.
Yeah,
Okay.
Facebook.
Okay.
And it's very customized for Facebook stuff. So like Facebook.
Yeah. Okay. Well, it's just like, Hive was originally a Facebook project. I'll have to research that, but thank you, I appreciate it. So I can't answer your question, but
No problem. I'm just, trying to learn.
I think there was a hand back here.
Do you see obstacles to just starting with building a yarn-based infrastructure, starting with, say, Hive, let's say, right? And then once you realize that Spark is, Shark has moved much faster, introducing Shark capabilities on top of that same data infrastructure. Do you see having to really pick something up front, or do you think as long as you really started and built a yarn cluster, you've got this flexibility going forward?
Can I ask, are you working with a specific Hadoop distribution, like Cloudera, or are you working with Apache?
Just straight up Apache. Straight up Apache, open source.
I don't think you have to decide up front that you're going. And can I ask what version of Apache?
Let's just assume the latest one.
The latest.
If I answered that in reality it'd be an old one, I'm assuming
it's
the
fine. In general, I'm not sure if you're asking if you have to decide whether you're going to use Spark from the get-go, or if you decide whether you're going to use Yarn from the get-go.
Well, I'm trying to decide, really between starting with Hive, which just seems to have gotten a lot of industry support. A lot of people seem to be familiar with it.
Right.
But yet, we hear that, Spark is moving so fast.
Right.
Does it mean you should kind of abandon your Hive experimentation and really just get on a Shark?
You don't have to have Yarn in order to run Spark. However, and I'm not an expert on Yarn, but I do know there are a number of benefits, and you absolutely need Yarn in order to run the legacy analytic application. In other words, Spark is already tightly integrated with the rest of the Hadoop ecosystem, right? It supports Yarn, so if you're using Yarn, it'll work with Spark. But if you're not using Yarn, you can still use Spark. Does that help?
Yeah.
So I think, first of all, you can run Spark over Yarn, or as standalone, so it's up to you. And the second, actually Shark is transparent to the user, so I think people know Hive. When you use it for the surveys, or the UDA, it's the same in Hive. So there's no penalty to move from Hive to Shark to Hive, which is very, very nice feature about Shark.
Thanks.
Was there another question?
Can you put your implementation on the link somewhere?
Can I what?
Can you put your implementation on the link somewhere?
Yes, we're going to distribute, and what I'm going to do is there's additional detail that I'm going to add in as an appendix, and then we'll distribute distribute it by PDF, and I'll upload it to SlideShare as well. Other questions?
It's not a question, but
go ahead.
still you sound there. But we organized the Spark meetup for Boston, and we are going to
It's
have
like a week from there.
July 15th.
July 15th,
So
okay.
presentation night. So whoever is interested in Spark, welcome to join. The event is sponsored by Rovi and the Databricks, so it should be fun.
I'm going. Yeah, Spark's pretty cool stuff. Spark Summit is in San Francisco, June 30th, July 1st, and July 2nd. The first day will be training. No, I'm not paid by Spark to plug it. I just think it's very exciting. Just Google Spark Summit 2014. Tickets still available. Are there any other questions?